أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. Hello students, the topic for today is electrical energy. As you know, there are various forms of energy. Electrical energy is one of the forms of energy that we have. Electrical energy is the energy of moving electrons. It can also be defined as the energy from electromagnetic interactions when charges are moving, such as electrons. The energy possessed by those moving charges is referred to as electrical energy. And electrical energy is very important because it can be easily converted to other forms of energy. Electric current is the flow of charged particles such as electrons. When charged particles are moving, there we say we have electric current. Electrical energy can be easily converted to other forms of energy such as light. Electric bulb, that is, you convert electrical energy to light energy using electric bulb. Sound, it can also be converted to sound energy using electric bell or radio or television, any device that can produce sound when electric current is passed into it. We convert electrical energy to sound energy. Example is the electric bell. It can also be converted to heat energy, as in electric stove or electric cooker or electric pressing iron. So electrical energy is very important. It is easy to be converted to any form of energy that is needed. If you need any form of energy, get electrical energy, you can easily convert it to other forms of energy. Conductors and insulators. You see, when you connect electrical energy, or you collect electricity to your various houses, you observe that we use wire, and the wire is wrapped in a kind of rubber. So that wire or the metallic substance that is wrapped inside the rubber is conductor, while the rubber covering is referred to as insulator. Electric conductors are materials that have mobile electrons and therefore allow electric current to flow through them. Materials that have mobile electrons, that is, those materials, the electrons are subatomic particles. Materials contain atoms. Inside the atoms, you have protons and electrons and neutrons. It is the electrons that can easily move from one atom to another. So when we have materials which has electrons that are free to move from one atom to another, such a material will be able to conduct electric current. It will be able to conduct electricity. So we refer to such substances as electric conductors. So they can allow electric current to pass or to flow through them because they contain mobile electrons. So we refer to them as electric conductors. Examples are metals. Metals are very good conductors of electricity. Metals have mobile electrons and they allow electric current to pass through them. Examples of metals are iron, copper, silver, lead, aluminium, sodium, potassium, gold, and so on and so forth. Insulators, on the other hand, are materials which do not allow electric current to flow through them because they do not have mobile electrons. Materials which do not have mobile electrons will not be able to conduct electricity. So electric current will not be able to flow through them. They obstruct the flow of electric current. That is, they do not allow electric current to flow through them. Non-metals are insulators. So all non-metals are insulators. They will not allow electric current to pass through them. Examples are glass, nylon, plastic, rubber, wood, that is dry wood, wool, etc. So those substances cannot be used to conduct electricity. So if you insert any of such materials inside the socket, you won't feel any electric shock. So they are referred to as insulators. They are referred to as insulators. Electric circuit. An electric circuit is a continuous path through which electric charges flow. We said that electric current, is a flow of charges. So that charge that is flowing has to pass through a certain path. It has to move from one material to another. So that connection of material through which electric charges flow is referred to as electric circuit. Electric charges enter the circuit through the source of charges. The source of charges may be a battery, it may be an electric generator, and so on. So anything that can produce electric current is a source of charges, and that charges move out of the source, such as the battery, and it passes through. It flows through. Wire is connected to the battery or to the generator, and the charge is now moving, passing through the wire, and it will be passing through any other component connected to that or through that wire. So all the components that are connected together through which electric current passes is referred to as a circuit, an electric circuit. The source of charges provides the energy required to move the electrons by setting up an electric field. So the source of charges, like a battery, will provide the energy that is required, the energy that is needed to move the electrons through the entire circuit. How does it do that? Is that it sets up an electric field which provides the electromotive force, EMF, electromotive force. That is the energy required to drive charges from the source throughout the entire circuit, electromotive force. The electrons pass through the other components and get to the load through which it leaves the circuit. The load is the appliance that you want to make use of. It may be a television, a radio, a bulb, a fan, etc. So as the electrons move, it moves out from the source of charge, it passes through the wire to the other components until it gets to the load, and that is the final destination. The journey continues again, but it lives through the load, because the load will convert that energy to whatever form that is needed at that particular point in time. Components of electric circuit. There are certain things that are connected together that forms the electric circuit. That is, certain things through which the electric current passes. The following are the main components of an electric circuit. Number one, the cell or battery, which is the energy source. Cell, the plural of cell is battery, and that is the energy source. That is what produces the energy. This is the symbol for cell. This is the symbol. You see, the horizontal line represents the conductor, the wire, through which electron is passing. and these two strokes represent the cell. The longer end is the positive end, while the shorter stroke is the negative end of the cell. When you connect two or more cells, then you have a battery. A battery is a connection of two or more cells. As you can see here, the cells are arranged in series to one another. The negative end of one of the cell touches the positive end of the other cell, and the two of them functions together to produce greater EMF, that is greater electromotive force. The second component is switch. You are all familiar with the switch. That switch is purposely made to connect the circuit or to cut off the circuit at required time. During the day, you will like to switch off your lamp, or you will like to switch off your anything that is using electric current. So the switch, that is the function of the switch. You see the gap there. That is when you press the upper part of the gap, it connects with the lower part and the circuit flows. And when you switch it off, there is a breakage. Then the circuit stops. Current stops flowing in the circuit. So switch is used to control the movement of current. We have another component referred to as resistor. This is the symbol for resistor. Resistor resists the flow of electric current, and in so doing, it converts it to other forms of energy, which we are going to discuss later. We have capacitor. This is the symbol for capacitor. It seems to look like that of a cell, but in the case of capacitor, the two strokes are of the same length. The two strokes are of the same length. In the case of the cell, the two strokes are of different length. As you can see, the longer stroke is the positive end of the cell, the shorter stroke is the negative end of the cell. But a capacitor has two strokes of equal length. The horizontal lines are just the wire or the conductor for the continuation of the flow of electric current. Then the fifth one is wire. Wire is a conductor. You've all seen wire before. It is used to connect all the various components of the circuit, and it can conduct electric current. It is usually made of metals. This is diagram of some of the components of electricity. We have resistor, we have capacitor, we have inductor, we have diode, we have LED, we have transistor, and we have IC, that is integrated circuit, we have relay, and we have the battery. Now let us talk about open circuit and closed circuit. An open circuit is a circuit. We have said that a circuit is a path through which electric charge can move. So an open circuit is a circuit in which the continuity has been broken by an interruption in the path for current to flow. A circuit becomes opened when current can no longer flow, when it cannot continue to flow due to breakage. Maybe the wire is cut somewhere. So when the wire is cut somewhere, it will not be able to continue. Then we refer to such a circuit as open circuit. This occurs when there is a cut on the conductor, when the conductor is cut somewhere. It may be intentionally. The cutting of the circuit may be intentional or unintentional. Maybe some rodents are passing by the cut of the circuit, or there is an accident and the wire is somehow cut. The cut may be deliberately created by using a switch, or you intentionally cut the circuit. Maybe you don't need the circuit to flow, you don't need the current to flow at that particular time, then you can make it open by switching. When you make use of a switch is just there to create a gap for circuit to become opened. When you turn off the switch, then there is a gap and the current stops flowing. Now, but a closed circuit is a circuit which is complete with continuous flow of electric current throughout. That is, there is no breakage, whether intentional or unintentional. The circuit continues to flow. A switch is a device designed to open or close a circuit under controlled conditions. So you can control the circuit to be opened or closed by making use of a switch. Look at this circuit diagram. We use symbol. When you are drawing circuit diagram, you are going to use the symbol. From the left at the top, you see a cell. That's the symbol for the cell, containing two strokes, longer and shorter one. From the cell, moving towards the right, you get to the resistor. That is the symbol for resistor. Then next is the bulb. You see the bulb, and now look at the lower part of the circuit is the switch. You can see that this switch is off. It is not on. This circuit is open because there is no connection. There is no connection here. The circuit has been broken here. That is, there is no continuity in the conductor conducting the electricity. Then we say that the circuit is opened. Here, the switch has been, has been put off. When circuit is opened, the bulb goes off. That is, you won't have light on the bulb because the circuit is opened. This is a diagram representing a closed circuit. As you can see here, the switch has been, put on here. It has been pressed, and you see there is a continuation in the conductor, in the connection of the conductor. There is no gap, there is no breakage, and you see that the bulb is, on here. You see the glow, the sign that the bulb is on. When circuit is closed, the bulb is on. When circuit is closed, the bulb is on. This is a convenient point for us to stop for today. Inshallah, we shall continue the next class. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين.